Hi everyone, my name is Arianna Totaram, and today I will be presenting the Wetterhahn accident. On the left here we can see the dimethylmercury compound that took part in it. Karen Wetterhahn was born in 1948 in Plattsburgh, New York. She spent a year working at Columbia's Institute of Cancer Research for the National Institutes of Health. In 1976, she joined Dartmouth's faculty as its first female chemistry professor. She co-founded the college's Women in Science project, which encourages female undergraduates in science majors. In 1995, with a $7 million grant, she started Dartmouth's Toxic Metals Research Program to investigate the effects of common metal contaminants on human health. Wetterhahn also conducted research into how our cells metabolize chromium and how the metal can cause cancer. She wrote over 80 research papers for scientific journals. On the left here we can see Karen Wetterhahn in her laboratory. Dimethylmercury belongs to a class of organic mercury compounds known as alkali mercuries. It is used primarily in research as a reference standard for NMR spectroscopy. It is a colorless liquid described as having a weak, sweet odor. It is readily absorbed through the skin, and it is highly reactive and flammable. The accident. In 1996, while preparing an experiment that involved the use of dimethylmercury, Wetterhahn spilled a few drops of the compound on her gloved hand. Though the latex gloves she was wearing were believed to be protective, they proved to be inadequate in preventing exposure to this potent form of mercury. Unknown to Wetterhahn, the toxin passed through the glove and was absorbed into her system. In November 1996, Wetterhahn began vomiting and feeling nauseous. Over the next couple of months, her condition worsened. Her speech was slurred, she had trouble seeing and hearing, and she was regularly falling down. After a series of spinal taps and CT scans, Wetterhahn was diagnosed with mercury poisoning in late January 1997, and soon after began a chelation therapy, as we can see in this image here. She began ingesting medication that would bind to the toxic chemical and help it pass through her body. Sadly, the level of mercury in Wetterhahn's blood was too high, 800 times the normal level for doctors to save her. So if you look at this end image here, her arteries were still clogged, and she had no normal blood flow. And unfortunately, she went into a coma in February and passed away on June 8, 1997. This slide here contains various articles I found that proves Wetterhahn did not die in vain. Her death changed the kinds of precautions scientists at Dartmouth around the world take when working with toxic substances. That same year, OSHA fined Dartmouth for failing to adequately train staff on the limits of disposable gloves, and they published a bulletin about Wetterhahn's death, instructing scientists about the precautions they should take in the lab, such as wearing impervious gloves and a face shield, immediately reporting spills, getting periodic blood and urine testing, when regularly working with dimethylmercury, and substituting less hazardous substances when possible. Her death also raised the alarm about the long time frame that can elapse between exposure and manifestations of mercury poisoning. Some frequently asked questions about the Karen Wetterhahn accident might be, what level of dimethylmercury is considered toxic? Absorption of doses as low as 0.1 milliliters can result in severe mercury poisoning. The risks are enhanced because of the high vapor pressure of the liquid. Another question might be, how long does it take for mercury to leave your body? Dimethylmercury is an organic mercury that can rapidly enter the body through the skin. Once organic mercury is in the bloodstream, it moves easily to most tissues and readily enters the brain. It can be changed by your body to inorganic mercury, and when this happens, especially in the brain, the mercury can remain there for a long time. Dimethylmercury leaves slowly over a period of several months, mostly as inorganic mercury in the feces. This slide contains the references I used. And thank you all for listening.